So what I'm going to do in the next sort of 45 minutes or so is to take you through some very personal thoughts about numeracy, numbers, maps, data, graphs, and try and frame it and contextualize it so that we as geographers can take meaning from information that we see and use on a daily basis, and in turn impart that understanding and those sort of reasoning skills to our learners that we'll be working with. So I've got kind of four main strands in today's session. One is looking at sort of what we mean by framing and contextualizing this data and quantitative skills. I've had a go at trying to think about progression of skills as well. It's very much a work in progress, but I'm sure you might be able to give me some feedback on that. Also, how, if you take a specification such as the WJC EDUCAS A-level, for instance, what opportunities are there in a component of it for getting some real data to make it come alive, make it have a deep context, and actually make it perhaps some challenges for learners as well in terms of understanding meaning from it as well. And then also sort of finally close on a few thoughts about quantitative skills and decision making. So let me just start by trying to frame and contextualize what I mean about this. There are arguably a couple of important people on this. One may feel more self-important than the other. But Andreas Schleicher, if you sort of follow him on Twitter or read any of his stuff, he's very well respected globally in terms of global education. And there's a lovely quote which actually comes from one of his TED Talks about the idea of what our future economy wants people to have as skill sets. It no longer pays for what they know, but what they do with what they know. And I think that's a really important context for what we're looking at today, making and reasoning and understanding. And Francis Maud has also worked, as I understand, in some sort of kind of data-y bits for government. And he describes data as the new material, or the material of the new industrial revolution. There are lots of other reports out there that also stress the importance of these kind of quantitative methods. So you have here an example of a piece of research which has basically been commissioned to look at what graduates going into kind of geography feel are the limiting factors for them understanding and being confident with numeracy. And right at the top there is this kind of fear of numbers, fear of mathematical formulae, fear of confidence of being able to perform procedures. Right down the bottom is lack of IT skills. Now, I think personally all of those are challenges that we can probably tackle in terms of our school-based geography. But perhaps if we look deeply in ourselves, they might be some worries that we have as well, and that might be one of the reasons you're sat in front of me at the moment, because of that context of fear as well. So this whole fear problem is important. Now, if you take statistics, which are a component of quantitative geography, or quantitative skills, however you phrase it, then statistics is not maths I don't think in the sort of purist sense. I don't mean by pure mathematics, but it's basically a logical, procedural-based way of processing data. It's something that computers are very good at doing. So you can set up a spreadsheet very easily to produce you an answer based on some data. And that's not the difficult thing. The difficult thing is making sense of the outcome from that data. And that's why I think we need to be empowering our learners to do that. And there's a nice little quote here about the fact that statistics really is decision-making in the face of uncertainty. That's what this is about. And it's about trying to work out whether the meaning from the outcome of the statistics makes sense geographically. The presentation that I'm doing today will be available on the WJC EDUCAS website, and there's some notes and links and things so you can download these reports if you wanted to. But there's some things in this report which also kind of emphasise the previous slide about why these quantitative skills are difficult to nurture. And the things that were put up as barriers, I think, are relatively easy for us as professional geographers to probably overcome. So perhaps we shouldn't necessarily view statistics as a sort of necessary evil, but just as a toolkit like we know how to do a lat and a long or a grid reference or something like that. It's just normal geography. And we need to make sure that we frame statistics as a communication of geography, and that's all it is. It's just communicating ideas, but perhaps through some numbers rather than words as well. I suspect another barrier for students is statistical terminology. I'm sure that many of you have had head-scratching sessions when you're trying to talk to students about null hypotheses, for instance, which are kind of counterintuitive, and they just don't make sense. Whoever thought of a null hypothesis? It's an odd phraseology. You're trying to prove something wrong so that you can prove it's right. So I think we get ourselves in a bit of a pickle with that. The second to last bullet point there, though, I think is very, very important, that perhaps we at school think we struggle with getting good data. And I hope that at the end of this session today, I can show you some ways in which you can get tons of data. It's very easy to come by now, and that you want your students to take meaning from that data. So getting the data is not difficult, it's the meaning and how you might process it. So we need to think about quantitative skills as offering a toolkit in geography for thinking about things a little bit differently. And we're doing this, well, I think, for these important reasons. We're doing this so that we can manage information, and then we can visualize it, and then we can understand it. Now, in maths, if you were talking to a maths teacher, they probably do the management, and they might do the visualization, but they probably leave short the understanding. So it's in our rich subject of geography that we try and encourage our students to make geographical sense of outcomes they see. And wrapped up in this whole idea of knowledge and information is this geographical thinking, and perhaps the idea of sort of big data, which again is something which is in the DFE criteria for the new A-levels that you've no doubt kind of sniffed your way through at this conference, is this idea that we can get complex data, and big data is actually quite a difficult thing to define. There are lots of things on the internet which kind of talk about it. It's more than it just being big, though. Big data actually has complexity in it. It often has velocity in it, and what that means is that the data is dynamic. So think about if you went to London and you stuck your Oyster card on the terminal of the gate to get into a tube station. Every journey that's being made is being collected by TfL to help them plan and understand, and they'll use some quite complicated GIS modelling to understand patterns and travels of movement. But think how many journeys are made on a single day and what you would do with that data. You'd have data of entry and exit points, and you'd also have data of interchange, what decisions people are making to get from point A to B, as well as how long their journey takes. That's big data. And the usefulness of big data lies at the top of that sort of almost like Bloom's taxonomy that's up there, is the knowledge bit, because the knowledge bit informs you about the next stage of decision making. The data itself is meaningless unless you know what to do with it and how to make sense of it. Now this is taken from a document which has just recently appeared on the RGS website, taken from a guy called Richard Harris who works at Bristol University, who's into his quantitative data. And there's an exercise, I'll show it to you if you have time at the end of today's session. There's a thing you can download from the RGS on this. And this is in his paper. And he cites this as an example of a piece of misleading information. And I'll just read you out some of the stuff that he's talking about with this, rather than trying to make you sort of hunt through it. But he talks about the fact that there is obvious bias in the graph for title, for instance. He sort of talks about this idea of 95% certainty as being something that we should really question from the data that we've got in front of us. What's less obvious is probably the fact that they're talking here a spectacular miscalculation. So what we have on the graph is climate science's predictions of climate change, temperature increases. The red line is the official modelling, 75-degree certainty, and the lighter red area is the 95% certainty, and the thick black line is the actual recorded temperatures. And this graph is implying that scientists are actually wrong with what they've talked about, because the trend of the data looks like it's going to extract itself outside of that normal area of the effectively of the model. And it hasn't crashed out. It's still within the model parameters. Okay, so it's misleading information that we've got here. And we need to be able to get our students to have the kind of conversation and discussion about data and information, I think at both GCSE and A level, at the complexity of the way in which perhaps I'm rather badly talking to you at the moment now, because this is really questioning things that we see is going to be very, very important. You know, do you trust what you see? Do you trust the information that you're being presented with? Another thing which I think is part of quantitative skills is words like open data and personal data. Now, let me just show you something. In front of you here is a screenshot from Google Maps. And on there are some red dots. Now, those red dots are places that I have visited. Now, if you've got a Google account and you have an Android phone, you can get this on your phone. I think if you've got an Apple account, or sorry, if you've got a Google account linked to your iPhone, you can probably get it as well. But basically, Google is tracking every movement that my phone makes, unless I specifically say I don't want it to do this. This would be an example of big data. So if I just show you on this screen, so this is a bit of a Blue Peter one, okay? So this is Google Maps at the moment. I've just typed in Google Maps and it's on my computer, so I'm logged into Google. It knows I'm at the University of Manchester. There is a blue dot there, it knows that, and it knows also something about the residency. It knows when I got here and it will know when I leave. It obviously doesn't know how long I'm going to stay here. It's not that clever. It doesn't know I've got to get, I've got to leave after this session. But look at this. This is my timeline of data for 2015. Each of these dots and locations represents places that I've been to. Okay? So if we look at the UK, these are all dots. Now, it's quite interesting because this is a kind of personal geography that I'm sharing with you here. I do live down in the southwest England, over here. Some of these are when I've taken my kids to the beach. Some of them are where I've gone to see my parents. There's a lot in London because I do quite a lot of work over there. There's some up in Shropshire here because I do some work for these good people at the front here, the Field Studies Council. So there'll be some kind of Preston Montford hits. But there's also a funny bit of data in here. And that funny bit of data is New York. Now, I have not been to New York ever. And yet, never ever. My other half wants to go there, spend lots of money, but I'm trying to dissuade her from that. This is error data. And it says that I've been to JFK Airport. Now, if I just click on this, I think what I get is the extract of the timeline. Now, it's quite interesting, this. So on the 2nd of November, I stayed at the A55 Holiday Inn, Chester West. Very romantic location. I then walked in the morning to McDonald's for breakfast. It knows I went there, and it knows I walked, because it knows the speed at which my phone is moving. It then knows I went and drove to this place, Neston High School. I did some work there, and then I drove to Manchester Airport, and I got to Manchester Airport at 16:42, and I left there at 20:07 on a plane. Now, that plane, it thinks, went to New York. It didn't go to New York, because if you go to the next day, it shows you something different. It says that I went to Malaysia. Now, I never even went to Malaysia. I actually went to this place here. I was lucky enough to be working for another awarding body, which I obviously can't mention now, but I went to the Maldives. Now, the Maldives doesn't even appear on the map because it didn't get the data right. So what's happening here is that my big data set, most of the time, is actually right, but it's wrong. Now, imagine in 10 or 20 or 30 years' time that this is going to become majorly important for different organisations, and, all sorts of different people are going to be looking at this, I guess, and trying to work out what's going on. I need to be able to justify why it looks like this. And as far as I can work out, the reason that that signal is being sent there is that I went on an Emirates aircraft out of Manchester, in one of those big 380s, and that when you get on the plane, you can get a phone signal on the plane. You can call from the plane. And the phone signal is registered with a geographical location for Manchester in New York. So as soon as I get on the plane and I go onto the on-air network, the plane or my phone thinks I'm in New York. And the reason it hasn't got any other information is because you're inside a metal box and it can't get a GPS signal. So the only data it can rely on is the data from the phone signal. Now, as a geographer, I've been able to sort of piece together what I think is the story there, but it's kind of fascinating. And I'd want my students, my learners, to be able to work out about that complexity, because I think that's important. So we've got open data, and open data again is going to become more and more important for different organisations and different people in the future. And I'm not sure whether my data in Google is open data. I don't know. You can't access it unless I gave you my password to log into my Google account. But Google has got it, and I don't really know who they might be giving it to in the future. And remember that, every time you go and swipe your rewards Nectar card or whatever in Sainsbury's or Tesco's, then they're collecting that data on you. And in the future, that data will become very, very important for those organisations to effectively keep tabs on you. Now, open data is something that we should also celebrate and not be worried about. It's data which organisations are making available for different users, end users. There's a lot of government organisations being able to being coerced into doing this, whether it's people like Environment Agency or Ordnance Survey, all sorts of different organisations are doing this, and it's about them being able to access and share with you, because actually that open data allows other people to create apps and complexity with it. That's very, very important, because that's the kind of creativity aspect of that open data. So I think we've got a better idea of what I mean by quantitative data, I hope now. Now, that sort of diagram, I reckon, can be adapted for skills, and I'm sure there are some people in this room who are working on that and thinking about it at the moment. And one of the things on the handouts that the good folks from WJC Educast have given you is a copy of this diagram, which I'm just going to make. You can see it quite big there anyway. I hope you can read it. Now, this is my version 0.1, if that makes sense. Okay, so it's beta version. It's out for testing. It's probably got typos and spelling mistakes and probably doesn't make a lot of sense at the moment. But I was trying to think, if I was in the classroom now, what I would try and do from Key Stage 3 to A-level in terms of upskilling. Now, there's been probably a lot of talk at this conference, not least from some of the awarding bodies, about, upskilling and needing to know how to do things like Mann-Whitney or chi-squared or Lorenz curves. That is one element of a skill set that we need our students to be able to do. But it's not, to me, the most important. Those things lie at the bottom of my set of skills. So I've got here specific qualitative and quantitative skills, including fieldwork. And these are largely things that I've lifted from the DFE criteria that the awarding bodies have used to create their specifications from. So that includes the statistical tools like, perhaps I don't know, probably things like modes and means and medians may fit in there at Key Stage 4. But I think what we're missing a trick on is the ones at the top. That doesn't mean they're necessarily more important, but they're ones I think are very, 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 very critical for good geographical understanding. And these are what I've classified as general data and information skills. Seeing significance in data. So recognising that facts and information and statistics can be analysed in order to develop knowledge. Know how to access open data and know how to get different types of data. So if I was trying to access some open data to do some spreadsheet work, I'd know that I'd want either an Excel file or a CSV file. It's no good giving it to me as a Word document or as a PDF. But if I wanted a report, then I don't want to see a report which is in a spreadsheet necessarily. So that is part of data. How is it delivered to you? The other thing is probably some bits about basic data manipulation skills. And again, they are very, very important. So when I work with students, one of the things I kind of show them is I show them, I'm just going to Google it out, something called gauge map, and I get them to sort of think about this. Now, this is an example of big data, open data, that a company very close to Shrewsbury have actually taken and have repurposed it for the general, general public so it makes sense. It is big data on rivers. Now, each of those dots represents a river location where there is a gauging station, and they're colour-coded according to the state of the river at the current time. Each of them actually has a Twitter hashtag as well, should you want to follow a river on Twitter. And I could just type in here, I'm just going to use the River Severn. I'm going to click the River Severn. Now, what I get is all of the data points in the catchment of the River Severn, which, is interesting at one level. But imagine I'm trying to teach hydrographs. Now, I'm imagining, I've got relatively young kids at the moment, but I'm sure that they're probably, already being introduced to the idea of things like, lag time and all of that sort of stuff. Now, I'd expect my GCSE students to know what lag time is and to know what a hydrograph is. And if I or if I asked them to draw a hydrograph, I know exactly what it would look like. And you can all mentally picture it, can't you? Now, let me show you what a hydrograph might look like in reality. Because what we're looking at is, if we went to Shrewsbury, is some river data there. That is the hydrograph. Now, that's never been in a textbook, has it? They don't look like that. Something wrong with it? Well, it's not, and if we had more time, I'd get you to work it out. It's just tidal. That's all it is. It's the influence of a tide on the water level. And if you look at it over, rather than just looking at it over a few days, we look at it over a month, then you'll see it does that. Spring and neap tides. What a lovely lesson. Now, this is data and real information that I'm showing you here, and this is all coming from the Environment Agency through someone else who has repackaged and repurposed it and has now sold it back to the Environment Agency for a lot of money. Great, isn't it? So geographers here are making money out of someone else's data. And this is very interesting because if you think of the likes of Google and all these other big organisations that have your data, are they not basically leasing you stuff now? That's what happens. If you want to, most of us, I'd imagine, particularly if we're of a certain age, relatively young, I'd imagine. I'm kind of including myself bravely in that age category. We don't go out and buy CDs anymore. We listen to stuff on Spotify. We are leasing information. And whenever I go and look for something on the internet, I'm basically leasing it from Google or from another agency. And I think in the future, that ability to understand that process of perhaps data leasing is going to be very, very important. So that's what I mean by data and information. The other thing is, sort of within those skill sets, is specific skills like data visualization, and that's an example of what we've just been able to see here. So can we make sense of things that we see in front of us? And there's a whole package of ideas linked into GIS, graphical skills. If I was an employer and I was asking a person looking for a job, can you draw a graph? And they'd say, yeah, I can do a pie chart and I can do a bar graph for you. And then you say, can you do anything else? Yeah, I can do a 3D pie chart for you or a 3D bar chart. It sort of stops there for some of our students because that's all they know about. And if you ask them the question, why are you doing that? Well, because that's the top thing I can do in Excel, or it looks the prettiest. Actually, I don't think that's that's an important skill. So perhaps you'll take this away and reflect on it, and if any of you want to email me with ideas, then I'd certainly be willing to incorporate those into that, to be honest. So just take a minute to have a little read through these with me. So the difference between kind of complicated and simple data. If I ask one of you the question, I'm not going to do it, but if I ask you the question how old you are, that is a non-statistical question. All right? There is a single answer. You might say, I'm 27 3/4, but you don't typically say that when you're 27, generally. You might do, but you generally don't say that. So there's a single answer. But look at the rest of the questions there. They are more complicated. Do you get paid working more as a teacher or as a fireman? Well, that's complicated because if you were running a very successful, large, independent school in the Middle East, then you'd probably get paid a lot more than even a top-ranking fireman. But if you're just working as a kind of normal teacher, how do you make those comparisons? Are we talking about an hourly salary? Because I reckon if you were thinking of a fireman who might be paid on every call they go out, they probably earn a lot more than a teacher per shout. So this is quite complicated. What about, does Cromer, that's where I was from originally, get less sunshine than Brighton? Are you talking about the total number of sunny days? What is a sunny day? Does the sun just have to come out once? Is it a bit like that, when you bet on whether it's going to snow on Christmas Day? Doesn't it just have to be a single flake of snow landing somewhere in London or something? It would be London-centric, wouldn't it? I'm not sure. But these are actually quite complicated questions when you don't look at them just at surface value. They're important to get people to understand the data. Now, I put this one in. This is on your sheet. I found this on The Economist a couple of years ago. Really interesting, because when I work with students on this, I get them to generate the questions. Now, this is UFO sightings in America, okay, reported by the National UFO Reporting Center. Dare I say it, I reckon if the National UFO Reporting Center had a conference like this, there would be even more corduroy jackets and that sort of things than there are possibly here at the moment. I don't know. You can imagine, probably more beards as well. But where do they get this data from on UFO sightings? Well, I suspect it has to be self-reported, first of all. So what does that make you feel? Well, you've got to believe in UFOs to report them, because otherwise you just assume it's an aircraft. And look about the sort of differences between the states. It looks like, Washington up there is the UFO hotspot. But when you look at and a couple of interesting things about Washington. One is that cannabis is legal in Washington, and the second one is that they manufacture Boeing aircraft there. So that might make you think differently about judgments on Washington. It's also pretty rural, I'm led to believe as well. But when you look at absolute data, it could be that in Washington there are 51 people who have said they've seen a UFO, whereas in, let's say, California, which looks like it's 2 categories down on this choropleth map, there are actually 30. Now, the map makes it look like Washington is the hotspot, but in reality, because of the way the map is drawn, it could be totally different. So we could change our scale and our way in colours and stuff to represent data in very different ways. The other thing is that I think, not sort of dodgily, but I'm looking at the word, trying to think of the right word really. I think in a slightly dangerous way, the economists have put an assumption of drinking hours linked to UFO sightings. Now, if you look at this graph, you're not likely to see UFOs before 5 o'clock, which is where the drinking hours happen, because you'll be indoors. And you don't see them indoors, unless they're very small, I guess. And it's also daylight. And you don't tend to see them in sleeping hours, because you should be asleep. Therefore, automatically, the time at which you see them corresponds with the drinking hours. So there's kind of an assumed correlation here. But would your students be able to look at that and kind of take meaning from it and make some assumptions about it? This one here, this is called Ansom's quartet. Now, Ansom was a statistician who developed this piece of kind of data to show the importance of plotting up data. So we have here 4 scatter graphs, essentially. And what is interesting about them is that the data which is used to plot them in a statistical sense is almost identical. So they each have the same mean. They each have the same variance. This is on the x and the y-axis. They each have the same mean on the y-axis as well. They have the same correlation. And yet, when you look at them, they're all very different. They don't tell you the same thing. So the geography and the story and the narrative here is very, very different. The other thing is, but are they able to contextualize it? So do they know that if you have, in a 36-hour period, 350 to 440 millimetres of rain, that's a lot or a little, Even if you live, I better mention Wales as I'm doing this for WJC, even if you live in Wales, that's a lot of rainfall. Even where I live in southwest England, that's a huge amount of rainfall. Yet we give it to students and they just sort of look at it often blankly, not having a framework to say, well, actually, where I live, I get 600 millimetres of rain a year, therefore that's like half my rainfall falling in 2 days or whatever. So it's about meaning from this. So I think we've got to expose students to these sorts of real bits of data and complexity, and to recognise the spatial elements in here. And you know, you could do some work on here, things like which direction are the rivers flowing out of this map. You know, you'd kind of hope they'd know that, but it's important. You've got catchment boundaries and stuff. So data is very, very important, and I hope you're, you know, sort of thinking about how important it is to sort of begin to celebrate it and to use it in different ways. One of the other handouts that has kindly been reproduced for us is some data here that might fit in with one of the core areas of many of the new A-levels, is the tectonic hazards. When you get all your books, which are fresh off the press, you know, as we're speaking almost, then they're going to have lots of up-to-date information in them. But they won't be up-to-date in 5 years' time. And one of the things I think about good teaching and learning in relation to quantitative skills is the ability of people to refresh their data and information from the right sort of agency. So this is CRED, which is, I think it stands for the Centre for the Research into the Epidemiology of Disasters. Gosh, that's difficult to say on a Saturday afternoon. But they have loads of data in here. Now, this data often is delivered in this format, which is a PDF publication. But if I'm trying to do something with the data, then actually what I want to do is go in and get other data. So you can get this sort of data from people like Hans Rosling, who was once a keynote speaker at this very conference that we're at the moment, Gapminder. You can download data in spreadsheets. And this, to me, is when the data takes on more meaning for students in many ways. This ability to look at data and to access it and to play around with it, rather than just presenting it to them and say, you know, this is what this means. Give them the story to tell themselves, so they create the narrative from it. And that's going to be very, very important, I think, in terms of getting students on board with you in this whole data and quantitative skills. So the final thing I'd briefly like to look at with you is how these quantitative skills are going to be very, very important as well in terms of particularly the independent investigation. And this is a diagram which comes from that document I was talking about, which is on the RGS website from Harris. It looks like this, if you wanted to download it. This is a copy of it. So this is the full version. Short introduction to quantitative geography. And it's actually very, very readable. And there's some interesting stuff in here, to be honest. And that's the diagram that I've used in my presentation, and you'll also see the other things in here as well. So it's worth having a look at, and I'd thoroughly recommend that to sort of, you know, support, if you wanted homework from this session, that would certainly be some, to have a look at that in comparison with this. We tend to think of quantitative geography and the math stuff that we're getting worried about, I think, in terms of those two circles there, the maths and numeracy and the descriptive statistics. But to me, like Richard Harris has said on his diagram here, it's much, much more than this. It's visualization, it's data handling, it's GIS, and it's also knowledge-based stuff as well. So is the data that's being presented to me real? Is it true? Do I believe it? There's obviously a strong degree of overlap between that data decision-making and the new NEA, or the environmental, sorry, it's not environmental, it's individual investigation. So the 20% coursework at A-level. So I think in order to be successful in this, you do need to have a number of kind of skill sets. You need to know what your quantification skills are, you need to know your fieldwork skills, but you also need to know research skills and meaning from unfamiliar data. And one of the reasons why Martin Evans, who works in this city, the chair of the ALCAB, who's the kind of peat bog man. That's why there's all peat bog and carbon stuff in your A-level, but also the systems-based stuff, is that he wants students to undertake an NEA whereby they do a bit of the jigsaw. So if you're looking at how a catchment works and trying to model inflows and outflows of a catchment, let's say, as your NEA, if you chose that, then what you would do is look at one very small piece of that jigsaw puzzle, and you would then extrapolate meaning into wider geographical research based on your knowledge and understanding of it. So to me, the sort of idea of going out and doing a kind of whole Bradshaw model or something like that that's really not appropriate for this sort of thing. And we never really used to get students criticising Bradshaw's model other than to say my river was wrong because it didn't fit Bradshaw's model. Well, you know, or, you know, does this small village that I live in fit Burgess's model? Well, probably not. Or if it does, what does it matter? Does it mean anything? And that's because the kids don't know enough about the provenance of either Burgess or Bradshaw's model. Bradshaw's model, as an aside, comes from an academic paper done in the late 1950s, Leopold and Woolman, who were the first quantitative kind of geographers who put together some bits of research and sort of presented it in a way that we might understand it nowadays. And they did that on large rivers in the US. So it's hardly surprising that when you go and visit, you know, the River Glaven in North Norfolk or Ashes Hollow, that it doesn't look anything like the model, because it's not at the same scale, it's not in the same country, and you've measured 5 sites that are 10 metres away from each other. So we need to get students upskilled in this. Reporting data and information, using good diagrams or criticising diagrams, using ways of measuring stuff, translating information from one form to another, describing information that's contained in different data sets, and recognising complexity. So there is a connection between an extreme weather risk and food and climate change and natural catastrophes and many other linkages. But that would be a fascinating way of saying, well, look, actually, I'm going to go and study in my NEA a bit about, I don't know, you know, changes in approaches to farming in my local village or something like that, if that's what they chose to do. I can link it to this, because this is the bigger picture stuff. And the other thing is that how is information presented to you? So we have not only that kind of matrix of interconnections, but we have here as well global risks in terms of impact. And what's interesting to me about this is there's a timeline, is in the last 2011, environmental risks, and this is from this global risk register, have become more frequent as a kind of reported box on here. And also the societal risks, which we actually probably think of as geography, are the #1 risks identified by this report in 2015. The other thing is that this data skills and analysis is another thing that we need to do. What's the difference between a sample and a population? We may use those contexts in field work, but do we really know what they mean, and do our students know what they mean? Do we know the difference between things like natural variability and experimental variability and error between them? And when we criticise data and information, we've got to move beyond, you know, my recording sheet got wet, or my friend was no good at using the ruler. We have to see whether or not we think our data is true and actually correct. So if you were to look at a data set like this, what would be the best way of describing from this data set here what a non-geographer or a non-technical specialist would recognise as being average income? Okay, now by that, I'm not talking about mean, I'm talking average in inverted commas, the sort of thing that the Daily Mail and the Metro write about a lot, okay? If you were to say on this diagram, the mean earnings are 29,000, well, that's, to me, a skew. Because actually, most people earn money, I don't know if you can't see my mouse on there, but where the peak is the highest. If you came to this country and you know, what's the likelihood you're going to earn this amount of money, then it's the peak, it's probably the modal value. Or at least I might go for the mean, because the median, I might go for the median, because the mean is influenced by those very rich people who live on the left-hand side of that, right-hand side of that diagram. But what I can do is at least I can have the discussion, because I'm looking at the data from a critical way. So about taking meaning and making assumptions is very, very important, I think. And if you were to think, how would I do this? How would I get some examples of data and information? Well, these are the kind of big portals, so there's 4 examples here, that you might want to be looking at. So you've got Wikidata, okay? Huge website like Wikipedia, which has got loads of data sets on it. You've got data.gov.uk, which all the big agencies, like we've mentioned before, Environment Agency, all those sorts of big government bodies have to publish data into. It's not for the faint-hearted. You go in there and you start downloading stuff, and you might download a spreadsheet which is 200 meg size. It's got a lot of rows in it. You'd open it up and probably your school computer would crash when you did that. So what do I do with it? I can't give it to students like that, or can I give it to one of them and ask them to sort of work out how to take some meaning from it and to repurpose it for the rest of the class? You've got Eurostat as well, and you've got a UN data portal. Now, there are hundreds of these, but I think it's part of our professional development that we should know that these exist, and these are kind of the gatekeepers of probably what we might call decent, reliable data. I mean, I know people have lots of issues with Wikipedia and stuff, and I'm not going to go into that, but these sorts of portals are well respected, and they're the places that other agencies go to get information as well. So what does this mean? Okay, take some meaning from this. This is something I found very, very recently. This is showing us that attacks on planes and airports have fallen dramatically since 1970. So it's now much, much, much safer to get on an aircraft or go to an airport than it was 30 years ago. Even though we've had those terrible things that have happened of late in places like Brussels, it is still much, much safer. And this is the problem that people like Hans Rosling talk about, is that we've got in our mind an idea about something and we don't back it up with analysis. This is the data. It's much safer to get on a plane now than it was previously, even though there are lots of nasty people in this world. And what you'd want to look at is this being proposed as an index? Is it absolute values? Is it relative? You'd want to be able to question it. Another piece of data here. I'll just look at the left-hand one. I'm not going to do the right-hand one now. Skyscrapers linked with impending financial crashes. There is a causal implied linkage between these two. Now, this is to do with the fact that economic cycles are on boom and bust curves. So when you have big, rich countries or nations spending on these, I think this is in Dubai, this is the Burj Khalifa or whatever it's called, that will have been built probably at the peak, or started to be built at the peak of the last financial boom. The time it's finished, 5 years later, we're in a bust period. We know these cycles exist. The skyscraper does not cause the financial crash. And just one final thing to share with you. Several people in this room know I'm somewhat of a travel geek, but there are other travel geeks in this room, so they can't criticise me too much. This is from Flight Radar 24. You can go and get live flight data anywhere in the globe. It's a really useful resource for sort of showing all sorts of things like connections, networks, lack of connectivity and stuff. Centred around Heathrow, these flights are separated probably by about 40 seconds, something like that. It was a screenshot I did yesterday on the train on the way. No, it was yesterday morning, I think I did it on the train somewhere. But I know from that the wind is in a westerly direction. Now, how do I know that? Because planes take off and land into wind. And I can actually verify some of these bits of information by looking at other pieces of data around. So if I went to the Met Office, I would hope that I could begin to make sense of that sort of data, which would verify my meaning and understanding of my aircraft movements in the UK. And I could even look at something like this. This is from Weather Underground. So this is for Hayes. This is where the airport is, London Heathrow. There is a chart on there showing me a graph from yesterday morning showing me that the predominant prevailing wind direction is 270 degrees, which is a westerly. And it all pieces together. So I'm not making guesses, I'm thinking geographically. Now, I reckon that if we're not careful, we have too much emphasis on this stuff with our new qualifications. Too much Spearman's rank, Pearson, am I allowed to say that? Sorry. Pearson product moment, Gini coefficient, Lorenz, all that sort of stuff. That's part of it. But these are procedural, and I don't think we should get hung up about these. We should use them. But to me, this is what we want to focus on. The quantification of data is about taking meaning. It's in the heart of the geography classroom, and it's to complement high-quality teaching and learning and to allow our learners to challenge and discuss and do all those sorts of things that the lovely Margaret Roberts talk about in terms of inquiry approaches and things like that. A lovely little sort of thing about enlightenment and seeing stuff differently. And that's what we want our students, I hope, to be able to do with numbers, and not to sort of think of numbers as a threat or as a challenge, but as a wonderful and integral part of geography and something that will get them a job which pays a lot of money. I shall finish there.